Hello friends, today I will discuss the light emitting diode, and in this case we cover necessity of this, construction, principle and application of it. When it comes to the necessity, the power absorbed by the LED is very less because the applied voltage is very less, so compared to the incandescent lamps, whereas in case of incandescent lamps the applied voltage is something around 230 volts and they take a lot of power, and then that converts into heat and then it gives the light, whereas in case of LEDs it takes the electrical energy and directly converts into light. So as the efficiency is high in LEDs, automatically the energy saving is more and its life period is very high, and its response is also very fast. That is, LED lights can be switched on and off very quickly without much delay. And when it comes to the construction, here we see the symbol of it and the component shape. This is the symbol, this is the anode and this is the cathode, and when this diode is forward biased, this anode is connected to the positive supply and cathode is connected to the negative supply of the DC supply. Then, and if the voltage is sufficient, that is 2 volts in that case, and at the junction the holes and electrons will recombine and they result in a light coming from the junction. And this is the component shape, and this color depends upon the light that is coming from that, and the light will be a visible light. And this small leg here is called cathode and the long leg is called the anode. This anode is connected to the positive supply and cathode will be connected to the negative of the supply. And this is the LED chip, and this is the bond wire, and this is the epoxy lens, and this is the reflective cavity, and this entire thing is kept in a cabin like this. It's a transparent component, so it converts electrical energy into directly light. So when we look at the construction of this, so the material that is used for the LED is a semiconductor material, that too eccentric semiconductor material. That is, they use the p-type material and the n-type material, and p-type material is doped with more number of holes, while n-type material is doped with the more number of electrons, and they are joined together and there is a junction that forms between p-type material and the n-type material. That junction has the distance, that distance is called the depletion layer, and this bottom one is called the cathode and the top one is called the anode. And the materials used for this LED are nothing but gallium arsenide, GaAs, gallium phosphide, DGAP, and gallium arsenide phosphide, that is GaAsP. These are the materials used for LED making, and these materials are nothing but semiconductor materials with doped materials. Means it is eccentric material, that is doped semiconductor or impure semiconductors. So this is the P junction and this is the N junction of the LED, and if the P junction is connected to the positive terminal and N material is connected to the negative of the DC supply, then it is called the forward biased. If the applied voltage is sufficient, that is 2 volts or 1.2 volts, then the LED is considered as forward biased, and the positive voltage will push the holes that are present in the p-type material towards the n-type material, whereas the negative of the DC supply pushes the electrons that are present in the n-type towards the p region. So at the junction they recombine with each other and energy is released from the electrons, and that energy is in the form of the light. And we can see here like this, this is called the depletion layer or is junction between the P and N. So when the sufficient voltage is applied between P and N, and Due to the recombination of the electrons and holes at the junction, it releases the energy like this. And it can also be shown simply like this. This is the n-type material, this is the p-type material, this is the depletion region, that is called forbidden gap. When the proper voltage is applied between P and N with proper polarity, that is P is connected to the positive terminal and N-type is material is connected to the negative of the DC supply, and the applied voltage is proper, then that is called the forward biased with proper voltage. In that case, the electrons will move towards the p-type material and holes will move from p-type materials to the n-type material, so that they recombine at the junction. They release the energy like this. Light energy means in the form of light. Light is shown in the form of blue color, whereas the holes are shown as like white balls, and free electrons are shown as red color, which are present in the n-type. And the recombination of the holes and electrons at the junction is called the electroluminescence. So that converts the electrical energy directly into the light energy. Next, coming to the applications, so here there are several applications of the LED, that is general lighting purpose, displays, indicators, automotives, that is for vehicles. Similarly, specialized purpose like laser LEDs, remote control of the TVs, medical equipment, decorative purpose, traffic signals, optical fiber communication, and so on. So let me summarize the LED here. LED means it is nothing but eccentric semiconductor material. P is doped with the more number of holes, whereas the n-type material is doped with the more electrons, and they are joined together, and joining point is called the junction. And if the anode is connected to the positive supply and cathode is connected to the negative supply, and if the applied voltage is sufficient, that is 2 volts or 1.2 volts, then it will be forward biased, and the recombination of the electrons and the holes will occur at the junction of the p-n materials. Then that releases the energy in the form of the light in the LED.